Gentlemen, welcome back to the shop. I'm all a Twitter on account of this treat especial. This is an iterative process. We are going to take pneumatic valvery, integrate it into a programmable logic control, program it with the confuser, and have this thing stuff corks like you never done seen before. Its final embodiment is not going to be that, but being married to a beautiful woman and who happens to be the mother of 2 young children, I could see why someone would want maybe the option of having a robotic fillator. It's been proven to you time and time again that despite my best efforts, I am not smart enough to comprehend complicated systems all in one go. Like a French Canadian will tell you, how do you throw the horse over the fence some hay? Step by each. So that is what we are going to do. We're going to figure this out step by each. And here is the valving that we have to control in order to get this thing a-chooching. And remember, the criteria is wicked fast out extension, nice slow retract. That's what we're aiming for. So what we have essentially is the input manifold here. We have a quick connect. We have a ball valve. That's just to turn off the hair so we don't have to do the quick connect all the time. And I've added a gauge. Why? Visual aids. It helps you to not get hurt if you know that the thing is pressurized. That's not to say that some of this other valving might be pressurized, but at least once the air has exhausted, you know we're not going to get any more air if this is sitting at 0. This goes in, so we feed in to the lower P port of this solenoid valve. This is a 3-position 5-way valve. Big hair comes in the bottom side topwise, compressed air into the P port. It's blocked. Here's the thing, the other thing. You get messing with this compressed air. It is dangerous. You don't think it's dangerous. You know, you breathe air every day. It ain't no big deal. But you get fucking around. You get doing these hijinks, this horseplay type deal. People die from this stuff. Just recently I read on Reddit, fella in India was dicking around in the shop. I just had an innocuous little spray, just a little air gun, you know, blast stuff off. Thought it'd be real funny. Stuck it up his buddy's butt. Give her a shot. Killed him fucking dead. Blew him up like a balloon. Internal bleeding. Nasty way to die. Imagine you killing your buddy for half a giggle. Real funny, eh? Yeah. Don't fuck around with compressed air, is what I'm telling you. So compressed air, a lot of stored energy. It's like a spring. Compressed air goes into P port. It's blocked off here. So this is a 3-position, well, you can see here, 3-position 5-way, 1, 2, 3, 4, 5-way solenoid valve. It's got springs on either end so that when you de-energize the solenoids, it goes back to the center position. This center position is a closed center. Every port is blocked off. You could also have this so that B and A port to the cylinder are connected. That would be a float. And you could have this so the P and the relief, the R, would be connected, and that would be a tandem center. Or you could have this completely open center and every port is connected to every other port. In air situations, most of the valves you're going to see are closed center. Now, initially I thought that was a problem, but I overcame that problem, and it's going to help us out because I was worried about exhausting the air quick, fast, in a hurry in that there cylinder. So I've come up with not a novel solution, but just adding an extra valve in order to get her to chooch faster. Now, when we want it to go one direction or t'other, we energize one of these solenoids. The spool in the middle shuttles over, and the relief port gets connected to the B port, and the pressure port gets connected to the A port. Cylinder extends. Then when we want to retract, goes the other way, flops those around. Now the cylinder, it extends. Now it retracts. When we energize this solenoid, that means we get air into here. This is a flow control valve, which is a check ball with a needle valve that closes off the flow on the other side. So in this direction, you can't see the schematic, but in this direction, it's free flow. It unseats the ball check and goes free into the blind end of the cylinder. This is a pressure transducer. We had it connected up to the oscilloscope. No longer. We're not dicking with that. The beauty about this is because it's got a check ball, when the air has to come back out, that check ball seats, and the air, instead of free flowing past the check ball, has to go through that needle valve. So we can control the amount of air coming out. That's to allow us to get a nice slow retract. Now, why would you want to meter? Well, here's the saying: when in doubt, meter out. So when we want smooth actuation, we meter out the air of the cylinder. If we metered in the air on this side to get it to come back, we'd meter the input air instead of the outlet air, what would happen is this would be far, far jerkier. This makes it so that there's a nice big fat spring in here and we have to force that air out, and it's much smoother than if we just sip air into there, and it fucks up the stiction and the diction. When we want to retract, we energize this solenoid, or we can actuate the manual override. That diverts air from the inlet over to here, loops around into the pressure port of this valve. This valve is normally open, so it goes directly into here, pressurizes it, forces the rod back, pushes this air out. That's a nice, smooth movement. Why this extra valve? Let's have a closer peek at that. As we see by the spring here, this tiny little squiggly line, the spring is on that side. When this valve is de-energized, we're in the first position. That means P, the pressure, goes directly to the A port, or in this case, the B port. However, when we energize this, it relieves the pressure in that A port. Now, why would you want that? Well, because working in tandem with the other valve, here, this is a closed center. So what happens is, I'll get you there. I'll give you a little money shot. So what this valve, this additional valve, allows us to do is when we want to fire very, very quickly, we exhaust the trapped air, the air that's trapped in here and in this line between the valve. Because everything, when this goes back to the center position, de-energized, any air that was in here is now trapped because it's closed center. What we are doing with this valve is we are allowing it to, the trapped air, to exhaust. So what we do here is when we want the air to exhaust, we fire this. Now here is where the PLC really shines, the programmable logic controller. It is a hell of a lot faster than a human hitting toggle switches. So what we'll be able to do is we'll be able to sequence this. We'll be able to have this fire for half a second before we fire this guy. Well, we can also, well, the beautiful thing is, because this is the closed center valve, there will be air trapped in this end of the cylinder, like a spring ready to explode, and then we exhaust the gas out of this end. Now this is zero pressure. It's going to want to start pushing forward. We'll see on the actual piece of equipment how I'm going to mitigate that. But there will be a coiled spring, essentially, which is air trapped in here, so that when we are ready to fire, we're going to have zero pressure in here, and we're going to have full chooch in here, and it's going to take off like a house on fire. We're at full pressure in here. We're going to fire this. Fire! Not very fast. What the hell is going on? Now this is completely pressurized. We're going to dump that hair out. That's a hell of a lot of air. Now we got zero pressure in there. Now, contact. Way faster. All right, got the old burner fired up, the coal-fired confuser. So what we got to do here is we got to take stock of our hardware. So we got to get this number off there because this will get plugged into yonder confuser. Here's the thing, the beauty about PLCs. It's programmable. It says so right in the name, programmable logic controller. So if we were going to use relay logic, relays and maybe some hardware timers and some push buttons, some momentary, some interlocks, this, that, the other thing, there is a hell of a lot of hard wiring, and that's not easy to change. In this case, we're using this. We can swap around whatever kind of signaling we want. So what we need is to figure out what kind of control we want. Now, we want this to be, of course, very safe. So we need an on button. We need an enable button. We need a retract momentary push button. We need a enable fire button. We need a fire button. We need, well, I think that's probably about it. And then all the indicator lights for that. However, cognitively, when you're otherwise preoccupied, engaged in the use of your cork-stuffing device, you don't want to be messing with buttons. Besides that, an ill-conceived idea deserves to be ill implemented as well. We're going to fire this dangerous thing with just the one momentary push button. You could spend $100,000 on a fancy-dancy enterprise system from IBM. They'll gladly issue the quotation. Or you can go and build yourself a Linux server box for 10 grand. This is the Linux server box. This is the minimum kind of viable for pseudo-industrial stuff. Of course, depending on what industry you're in, you're going to want some legacy and support and all that sort of stuff. So you got to decide. But this is what we're using. And the reason I'm using it is cheap. The second reason I'm using it is because it's cheap. The third reason I'm using it is because it's got free software. You see a theme happening here, because if you get into the ABBs, you're looking at 5 grand for a seat just to program the Jesus thing. Now, once we get into the programming, I'm afraid you're going to get visual aids. The good thing about visual aids, you can't catch it twice. However, PLC ladder logic it has all the intuitive userness, the intuitive interaction of COBOL with the ease of use of assembly. But it is good for people who are not programmers, because it's schematicized contacts, just switches on the one side of a rung, and then an output coil on the other side of the rung. So it's just switches and coils. Now we got the Click PLC open. No, we want the new project. So we start a new project. We need the number. So that was a DRD, I believe, 1 DRD. We'll be able to change it after the program, but it's just easier. So we start out, and I will cut out the boring part, so if there's some non-cicators, it's okay. So now we have 1 button and 3 solenoids. So we'll go ahead, and this is janky as frig here. You got to hit edit mode, and you want to give everything a nickname so that, you know, X001 doesn't tell you anything. These are the inputs, the X's are the inputs, and the Y's are the output coils. T is a timer, and then a counter, all sorts of data types. But anyway, so we'll go nickname for this guy, that 1 button is fire. And then we'll name some, while we're at it, we'll name some coils as well. The first coil is going to be the retract coil, solenoid. Jesus. You want to name these as easily as possible. There are many ways to kick a cat, but you want to keep it as simple as possible, because, as any programmer will tell you, it is easier to actually write the program than it is to read the program. So you want to make this as easy as possible for someone to troubleshoot, because they are not going to rewrite an industrial program. Now we got to select it. We got to go OK, and it populates this normally contact open, normally open contact, normally open. Jesus, that's a mouthful. That is your fire button. And let's change that. Edit mode again with the Jesus thing. This is, yeah, button. let there be no doubt. Save some headache for the next guy, because the next guy is going to be you. And that should actually be cancel. That should actually be a normally closed. I'm talking. So same thing. Normally closed. We go in here into the table X001. So then we hit a coil output, which is going to be the retract solenoid, which we choose over here. We say OK. We say OK. Now you go normally open contact, and we will say that same fire button. OK. And now when we depress the fire button, it is going to fire the exhaust solenoid. Okay. Okay, now here's not fancy footwork. This is as dirty and easy as we can do it. We're also going to go normally open contact. Or should we? Yeah, we'll do normally open contact. Just keep it simple on the fire button. Okay. Okay. And you never know if it's going to work. So, you know, stay tuned, because you might see I'm making a huge mistake. We're going to put a timer in there. So when this fire button closes, when you press this fire button, we are going to start a timer. We're going to call it the fire timing. Got to edit mode. We're going to call it the exhaust delay. Yeah, we'll call it the we'll call it the fire delay. Fire delay. And we press OK. Then we select it, we press OK again. And then it populates. The set point, we're going to set the set point to that's weird. DS1, which is an address, but no, I don't want that. I want that set point to be 1000 milliseconds. And that's going to be an on delay. Yeah, that's right. So when we hit the fire button, it's going to wait 1 second. Oh, that's far too long. 100. It's going to wait 100 milliseconds before it does an output. So we hit the fire button. Power goes through here. It goes to the enable pin of this virtual timer. After 100 milliseconds, it's going to fire this timer. So this timer isn't connected to anything. It's only virtual. It's not like a solenoid, this Y01. It's only virtual. So now we're going to go normally open contact, and we're going to tie it to this output. We go to timer 1. OK. Gotta hit the OK button like a bazillion fucking times. And now that is going to fire. What do you think it's going to fire? It's going to fire the advance solenoid. Okay. Could say extend, but then everything is extend, exhaust, retract, and well, not everything. Okay. Now that, what's going to happen here? What's going to happen? We need an end. I think we need an end. And I think that's going to work. Okay. So the thing starts up. You're going to hit the retract solenoid. It's going to come back in a hurry, just as soon as you fire up. Then when you're ready to actually get the thing to extend, you hit the fire button. It's going to fire the exhaust solenoid. So it's going to exhaust that pressure in the retract side of the cylinder. Then it's going to count for 100 milliseconds. And then after 100 milliseconds, it's going to blast the advanced solenoid. So it should shoot out of there like a... Now we take the PLC, physically put it in stop mode, and then we flash it up. It stopped. We put the RS-232 or 4, whatever the fuck it is, serial data into the correct port. An Ethernet port will have a metal bezel. So this goes into the sort of phone port. And you got to have one of these programmers unless you buy the Ethernet model. You're probably better off buying the Ethernet model because this thing is like $30 or something. And the Ethernet model, whatever. It is what it is. Just figure out what you want. Now this little dongle, USB, how you do this is you stick it in your computer and it won't go. So you turn it over and you stick it in this way and it still won't go. You turn it back over and stick it in and she'll go. Now we go over here to PLC. We can go to instruction program. We will syntax check it. 0 errors, 0 warnings. Perfect. Now we go to PLC and we go, well, this is actually kind of nice. Write project into the PLC. On old legacy stuff and in some PLCs, they say upload and download, but it's from the PLC itself. So you'll go and say upload. You'll be on your confuser, you'll say upload, or you say download to get the, yeah, it just fucked. It's fucked. It's the exact opposite of what you would think it is every single time. Sort of like the USB key. So here is pretty clear language, write project into PLC. So we go ahead here and we hit write project into the PLC. Got no errors. It's offline. Okay, so we'll go connect, see if it connects. Here's our status, the connection state, online. The PLC is stopped. There are no PLC errors. We are good to flash this. So we're going to write the project to the PLC. Alright, well that was almost painless. So we're going to run this and Y1 should come on right away. That's the retract solenoid terminal. There we go, nice red indicator light. Now we are going to stimulate the use of the button. Trap for young gamers is the common needs to be tied to ground, the 0 volt DC ground. Otherwise it won't work. If you try and have a high input on this, internally these are not connected to ground for whatever reason. So we need to give it a ground. And then when we fire this, we should get, I know you're thinking smoke, but what we should get is Y2 and Y3 fire. Y2 fires, and then 100 milliseconds later, Y3. And of course, that's the exhaust Y2, and then the actual advance. So there you have it. Alright, got her kind of sort of wired up here. We'll feed her 120 volts of Angry Pixies. Watch for smoke. This is the typical arrangement just while we're testing the bird's nest, and then after we're done we'll clean it up. Nothing more permanent than a temporary solution. So we'll put that in stop, and I flash the new program. I got the switch here momentary, and the input's working. Now we'll stick her in run and see how she does. This Y1 should turn on. Yeah, you heard it click. And let's have a look. We're fully retracted, got 100 milliseconds on the timer for the exhaust valve contact. Now the exhaust is going to run for 1 second, 1000 milliseconds. Runner, we got the contact. Much quicker, much quicker. While the testing was successful, we can definitely use some more features. Good projects require feature creep. Also, I didn't mention to you how I am dealing with the 12 volts that these solenoids need. This is 24 volt system. So what's going on? Well, I know from experience that these need about 350, 400 milliamps. So figure half an amp, V equals IR, 12 volts divided by half an amp gives us 24 ohms. Now I have 24 volts, so I want to limit the current going to them. I don't want to fry them. So all we need to do is add 24 ohms that can handle that much power. So I have 20 watt resistors. They're 20 ohms, so she gets a little more chooch for her chotch. They don't get too hot and they actuate nice and quick. Essentially what's happening here is, even though I'm feeding it 24 volts directly, because it's going through this dropper resistor, it's dropping 12 volts across this resistor. And then the coil sees 12 volts, so everything works perfectly. Puritanism aside, you know, I am a married man of formerly convicted Roman Catholicism, so I do have my hang-ups, but you know, yeah, people got disabilities and so forth. They're not able to polish their own hammer handle. So we're gonna change the program a little bit. So what we gotta do is a blink ladder logic, and as opposed to an Arduino blink program, it's actually quite a bit more complicated, a bit more fucking around. Now, what's the difference between an Arduino and a PLC? Well, the PLC is hardened for industry. Arduino could do this, but you'd need some outputs. All the outputs are real finicky and not very robust. It definitely can't handle 24 volts. And the other thing is it's glitchy. So you'd never want to have some sort of industrial process or anything that you're not babysitting. You wouldn't want to have it on an Arduino because they glitch out. They totally glitch out very frequently. Now this I am going to put on a timer. We will call it T2. And we will edit that into hammer stroke time. Okay. You no doubt see where we're going with this. Memory address T2, and that's a normally closed. Now what we do is we put the timer in there, which was T2, okay, and we put the milliseconds as 1300, and we say okay. Now what we do is we do a normally, no, not a normally open. What we need is larger than or equal to, why doesn't that work now? Larger to, oh, there we go. Oh, you got it. It's so fucking janky, Jesus. Okay, so the data set is, or the data is in timer TD2, okay, and data B will be 600 milliseconds, say. Yeah. Okay, so now it's going to check the value of this timer, and if it's less than 600 milliseconds, it's going to close these contacts, and we'll have that fire. What are we going to have that fire? We'll have that fire the retract solenoid. Okay, and that's that. Now, same thing, we come over here, we highlight it. I don't know why we can't bring it over. It's weird. We do the alligator the opposite way, less than or equal to data set. Same data set. We're going into TD2, which is that timer value. And then we set that 601. Okay. And then we'll have that fire 2 relays. A special note here. If you want to fire 2 relays with the thing, well, you could do another ladder run, but you got to have them side by each in the listing here, and you have to go in the right order, because if you go backwards, it'll tell you Okay, so those are the 2 solenoids. Okay, so when it's over 600, this will turn this one off. When it's over 600, it'll turn these guys on. And the fire button, looks like that's it. We need an end, and Bob's your auntie. Let's upload that and see what happens. All right, contact. Not quite right. Let's open this valve up. Witness now the reason you do not give out your mailing address on the internet. Someone will send you one of these, especially if you give them your credit card number. Okay, let's contact. Releasol, no fucking good at all as a personal lubricant. Didn't polish it. Oh man, that's some uncanny valley shit there. We have reached an all-time low. She's seen better days. Thanks for watching. Keep your dick.